Before we go any further, if you value deep, serious history that treats the past as a source of hard-earned knowledge rather than entertainment fluff, subscribe to this channel now. This is a legacy of survival space, built for historians and survivalists who want substance. Share it with someone who understands that survival is a discipline, not a trend. Now, let's get into it. War does not reward theory. It rewards preparation under pressure. During the Second World War, soldiers across Europe, North Africa, and the Pacific learned very quickly that survival was not just about weapons or armor. It was about where you stood when the bombs fell. Air power had changed warfare permanently, and soldiers on the ground were forced to become engineers, geologists, and architects almost overnight. What they built beneath their feet often meant the difference between life and death. These were not crude holes in the ground. These were carefully engineered shelters designed to absorb blast waves, redirect pressure, and disappear from aerial view. The urgency of air bombardment forced soldiers to rethink shelter design completely. By 1940, bombing campaigns had proven that traditional trenches were no longer enough. High explosive and delayed fuse bombs could collapse shallow dugouts with ease. Soldiers began constructing shelters that worked with physics rather than against it. Depth became critical. Most effective WWII field shelters were dug at least 8 to 12 feet below ground, not arbitrarily, but because soil density at that depth could absorb shock waves instead of transmitting them. German and British field manuals emphasized this exact range based on battlefield observation rather than theory. The angle of entry mattered just as much. Straight vertical shafts allowed blast pressure to travel directly downward. To counter this, soldiers engineered dogleg entrances, typically with 2 sharp turns before reaching the main chamber. This forced blast waves to lose energy before reaching occupants. This same principle is still used today in hardened military bunkers and can be applied in modern survival shelters by ensuring entrances are offset and never direct. Soil, timber, and sand were used as calculated shock absorbers, not random materials. One of the most misunderstood aspects of WWII shelters is material choice. Soldiers did not simply use what was available, they used what worked under stress. Dense clay soils were preferred over sandy ground because clay absorbed energy rather than shifting. In sandy areas like North Africa, shelters were reinforced heavily with timber and sandbags packed tightly to prevent collapse. Wooden supports were placed deliberately close together, often no more than 18 inches apart. This spacing was learned through failure. Wider spacing led to cave-ins during near misses. Roofs were layered, usually with timber, then earth, then a final sandbag layer to prevent spalling, where fragments of earth or wood become lethal shrapnel inside the shelter. Freshly dug earth was deadly obvious from the air, so spoil was scattered thinly over wide areas or dumped into existing craters. In wooded regions, sod was carefully lifted and replaced to hide any disturbance. Roofs were often built slightly below ground level to avoid shadows, which, reconnaissance pilots were specially trained to spot. This principle applies directly today. Any survival shelter that alters the natural outline of terrain becomes a target, whether from aerial drones or human observation. The lesson from the Second World War is simple and, unforgiving. If it can be seen, it can be hit. Concealment is not decoration, it is defense. Ventilation and blast management were solved through practical trial and error. One of the deadliest early mistakes in Second World War shelters was poor airflow. Bombs consumed oxygen and produced toxic gases that seeped into enclosed spaces. Soldiers responded by creating multiple ventilation shafts with bends, never straight openings. These shafts were often lined with cloth or fitted with simple baffles to trap dust and debris. Critically, shelters were rarely airtight. A completely sealed shelter could, collapse inward from pressure differentials. Second World War designs allowed controlled leakage, preventing catastrophic implosion. By the later years of the war, particularly on the Eastern Front and in Normandy, soldiers built interconnected shelters rather than isolated dugouts. These systems allowed movement underground during bombardment and reduced casualty concentration. A single hit might collapse one chamber, but others remained intact. From a survival perspective, this teaches a critical lesson in decentralization. One shelter is a point of failure. Multiple connected spaces increase resilience. Even on a small scale, dividing a shelter into compartments can prevent total loss from fire, collapse, or flooding. Applying Second World War shelter principles today remains, frankly, brutally relevant. Modern tools may be better, but the physics has not changed. Shockwaves still travel, pressure still seeks straight paths, and visibility still attracts destruction. Anyone building a storm shelter, remote survival bunker, or even a reinforced cellar can apply Second World War lessons directly. Dig deeper than comfort suggests. Offset entrances, layer materials, disguise disturbance. Never rely on a single barrier. Second World War soldiers survived not because they were lucky, but because they learned faster than the bombs fell. Their shelters were not perfect, but they were intelligent responses to a changing battlefield. That mindset, not the tools, is the real inheritance. If this kind of deep, no-nonsense history matters to you, subscribe to the channel, share it with fellow researchers and survivalists, and help keep this knowledge alive. This is not nostalgia. This is practical history, and it still saves lives.